Okay, next experiment is determination of thermodynamic solubility product of potassium hydrogen tartrate, KHT. Determination of thermodynamic solubility product mean KT. Okay, so we are going to find out thermodynamic solubility product of potassium hydrogen tartrate. However, there is a theory behind this KT. When the temperature is constant, we can calculate this thermodynamic solubility product. Actually, it is a theoretical one. We can calculate it after getting activities of chemicals. However, I am not going to talk about these activities. Please go through your level 3 notes. However, we can calculate this. Here we know potassium hydrogen tartrate is a weak acid. It will dissociate into K plus and Ht minus. We are going to we have to know, calculate the concentration of this Ht minus. We have to calculate the concentration. According to this reaction, it is a reversible one. In equilibrium, samatulita avasthawedi, Ht minus concentration will equal to K plus. If we know the Ht minus concentration, hydrogen tartrate anion concentration, if we know, we can know the potassium ions concentration because stoichiometry is 1:1. So we are going to calculate this Ht minus concentration. How? To do that, we are doing a titration with sodium hydroxide with using phenolphthalein. However, to calculate this, we have to conduct an experiment by using, because this is a weak acid, partially dissociation. Because of that, we can't directly measure the concentration. We have to do some series of experiments or steps to achieve the concentration. How? First of all, we have provided sodium sulfate solution. We have provided its concentration is 0.5 m. 0.5 m stock solution we have provided. By using that, we have to dilute and we have to prepare 100 ml of we have to use volumetric flask to prepare these solutions. By using this stock solution, we have to prepare 0.1 m 100 ml, Ola 100 ml, 100 ml 0.1 m sodium sulfate solution and 0.05 ml 0.05 m solution, and this is without the analyte, that means only distilled water. It is 0.00 m sodium sulfate. Actually, there is no sodium sulfate in this fourth solution. So, likewise, we can get 4 solutions. First one is this one, stock solution, and 2, 3, 4. That's the first step. We have to prepare 5 different concentrated sodium sulfate solution. Why is that? We have to achieve 4 different ionic strength, because concentration of this partially dissociated anion is depend on the ionic strength of the solution. Solution එක ionic strength එක මත concentration එක රඳා පවතින හින්දා අපි different concentrations තියෙනවා. සාන්ද්‍රණය වෙනස් නැත්නම් ionic strength එක, because sodium sulfate Na2SO4 fully dissociate into Na plus and SO4 2 minus. මේ විදිහට dissociate වෙනවා. So because of this dissociation, we can get a particular ionic strength. මොකක් හරි ionic strength එකක් ලබා ගන්න පුළුවන්. Ionic strength mean there is a popular equation to achieve the ionic strength. Ionic strength is equal half summation of concentration and charge number, square of charge number. එතකොට මේ by using this equation you know the concentration and you know the charge number. Charge number mean the electrons. When this is ionizing here, we can achieve the electrons. Here 2 electrons are dealing. So according to by using this data, concentration and charge number you know, by using them you can calculate ionic strength. Okay. However, there is a popular equation for this potassium hydrogen tartrate dissociation, Kc log 10 base Kc is equal 0.509 square root of ionic strength and 1 plus 1.1 plus 1.25 square root of ionic strength plus log 10 base Kt. So after doing this experiment, the aim, we will calculate this Kc and we will know this ionic strengths. All the other values we know. By calculating I and this Kc, we can plot a graph. Its intercept of this graph antak kanden apita we can calculate Kt. We can get that value from this graph. So our aim, we have to calculate Kc. To get Kc, we have to know the concentration of hydrogen iodide anion and concentration of our potassium ion. Their product will be Kc. So we have to calculate the Ht minus concentration. That is the aim of this experiment. So when we are calculating concentration of Ht minus, it is equal to K plus. So we can get the concentration of potassium ions. By their product we can calculate Kc. We can get log 10 base Kc and we can calculate ionic strength by using this equation. After that, by there may be a graph like this. Its intercept we can read the Kt value. That's the aim. So to achieve this calculation, we have to do this experiment. First of all, we have to prepare these 4 solutions containing different ionic strength. Here 0.5, here 0.1, here 0.05 and here 0.0 mean no sodium sulfate, just distilled water. So after doing this, we will prepare, we will measure 50 ml. 50 ml of this sodium sulfate solution into 4 different stoppered bottles. We have to label everything. We have to label everything because if you don't label, after some time you will messed up with that. We can't identify which solution in what vessel. So we have to label everything, every stoppered bottle and every these volumetric flask also we have to label. Okay, this is 1, 2, 3, 4. We got 50 ml of this each solution into 4 different stoppered bottles. And next, this is second thing. First thing is preparation of these solutions, dilution and 100 ml solutions. After that, we measured 50 ml of this solution into this stoppered bottles. After, we will add 1 gram of potassium hydrogen tartrate salt. we will add these potassium hydrogen tartrate into each solution 1 gram per 1 stoppered bottle, 1 gram, 1 gram, 1 gram and 1 gram. Why is that? We will add potassium hydrogen tartrate. This is partially dissociate and not fully dissolve. However, this will not fully dissociate. I'm sorry. However, after that, we have to shake these stoppered bottle very well. We have to slide very well because we have to dissolve every potassium hydrogen tartrate grams, 1 gram. However, after 10 to 15 minutes or after some time, more than 20 minutes, so you can swallow very well. After some time, we can see there are some undissolved potassium hydrogen tartrate. How much we swallow or mix this remaining potassium hydrogen tartrate will not dissolve. That means these are saturated. So we need saturated potassium hydrogen tartrate solution with different ionic strength. So we achieved that because these remaining potassium hydrogen tartrate will not dissolve further because now solution is saturated. After getting this saturated solution, we have to filter. We have to filter very well. This filtering step also very special because we have to use 4 filter papers for 4 solutions. 4 different filter papers we have to use. We can't use 1 filter paper for filtration process. For 4 solutions we have to use 4 filter papers. And there is another thing. When we filtering, there is a special thing. Imagine here our conical flask. We are going to collect our filtrate into this conical flask. This is the funnel stand. This is your funnel. And this is the filter paper, fluted filter paper. However, before collect the filtrate, we have to add around 10 ml of solution. We have to pour 10 ml of solution throughout the filter paper. We have to wet the filter paper. අපිට මුලින්ම filter paper එක පොඩ්ඩක් තෙත් කර ගන්න ඕන අපේ solution එකෙන්. අපි මිලිලීටර් 10ක් විතර මුළු filter paper එකේම හොඳට විසිරව ගන්නවා. ඇයි? We have to saturate the filter paper first. We have to saturate the filter paper first. So we will add 10 ml small amount of solution. One of the first we will get first solution. This first solution we will filter first. So we will get 10 ml of this first solution and we will add into the filter paper and we will allow the filter paper getting wet. අපි මේක පොඩ්ඩක් තෙත් වෙන්න දෙනවා or saturate. We allow it to saturate first. After saturation, some amount of from that 10 ml will come to this conical flask and we will discard it. Because concentration is now different because some amount of water absorbed into the filter paper. Filter paper එකට යම් කිසි ප්‍රමාණයක් absorb වෙච්ච හින්දා දැන් මේ filter වෙලා මුලින්ම filter වෙලා එන අයගේ concentration එක හිතුවට වඩා අඩු වෙනවා. Because of that, we will discard first 10 ml and after discarding, now we can filter whole solution because now the filter paper is saturated. දැන් filter paper එක saturate වෙලා ඉවරයි ජලයෙන්. මොකද නිකම්ම filter paper එකට අපි මොනවාරි solution එකක් දැම්මොත් filter paper එකෙන් absorb කරගන්නවා water. ඒ solution එක. එතකොට යටට එන කෙනාගේ concentration එක වෙනස්. ඒ නිසා මුලින්ම filter paper එක saturate කරලා ඊට පස්සේ තමයි අපි filter කරගන්නේ. Now we will filter our first solution which containing undissolved potassium hydrogen tartrate. Potassium hydrogen tartrate will remain here. Now the solution will come. We will get precipitate less or deposit less clear solution. අපි හොඳ solution එකක් filter කරගන්නවා. Okay, that's the thing. Likewise, we have to use different filter paper for next one. We add new filter paper and new new conical flask and new funnel also, new funnel, and again we will saturate the filter paper first by using 10 ml of second solution, and we will filter next. Likewise, we will get 4 different saturated potassium hydrogen tartrate solution. After that, we will titrate what is the volume? We will get 10 ml of potassium hydrogen tartrate solution, and after that we will get 10 ml, 10.00 ml from this filtered, this means filtrate, no? From the filtrate we will get 10.00 ml. 10.00 mean 2 decimal place mean we have to use graduated pipette or 10 ml pipette. So we will get 10 ml pipette. I will erase this. We will get 10 ml and we will add into titration flask that 10 ml of KST solution. This is first solution with 0.5 m ionic strength. So saturated solution we will titrate it with sodium hydroxide. We will add an indicator, that is phenolphthalein. Likewise, now by doing this titration, sodium hydroxide will react with or titrate with St minus ions in the solution. St minus ions, St minus plus NaOH. Here St minus, there is another, okay, here sodium hydroxide will react with St minus. Here St minus mean you know tartaric acid structure. If we consider OOC, here minus, one hydrogen will replace with potassium, here remaining CHOH, CHOH and COOH. This O minus will bind with K plus. Here potassium, and this is tartrate ion, St minus. However, it contains another COOH group, carboxylic group. That COOH group will react with sodium hydroxide. That's the aim of this titration. So sodium hydroxide will react with St minus, that means this COOH. So we can achieve the volume. We know the volume, used volume of sodium hydroxide we know the concentration 0.4. By using the volume and this concentration we can calculate the amount of sodium hydroxide required for this experiment for first reading, first solution, first ionic strength containing solution. So by using that amount, according to the stoichiometry, we can calculate the St minus ion, amount of St minus ion, and we can calculate the concentration of St minus ion in the mixture. By using that concentration is equal to K plus ions. So that by using this concentration value we can calculate the Kc. So we know the concentration of this ionic strengths. We know that by using this ionic strength equation we can calculate the ionic strengths. So we can use that equation. Log Kc is equal 0.509 1 plus 1.25 plus log 10 Kt. So now you can calculate Kc. So you have to do this titration for other solutions also. There are another remaining 2, 3 and 4. You have to titrate these solutions also by getting 10 ml. You can get the Kc values. So you can plot Kc versus this part 0.509 and 1 plus 1.25. So you can plot a graph. So by the data of this graph you can calculate the intercept. By using that intercept you can calculate the KT value. The special things in this experiment, we have to maintain the temperature at room temperature. That means here we have to maintain the 25 degrees Celsius, because the Kc and Kt values are depend on the temperature, thermodynamic solubility product. So here we have to maintain the temperature at 25 degrees Celsius. To do that, we have to use a water bath by adding ice cubes. We have to add ice cubes, and we will use a thermometer. We will check whether the water bath in 25 degrees. After getting 25 degrees, we have to dip all of these solutions in the water bath before start the experiment. Before start the experiment, we have to keep all solutions in this water bath at 25 degrees Celsius, because Kt is depend on the temperature. Okay. So what are the special thing in this experiment? We have to use clean glasswares. You know that. Cleaning steps I mentioned in previous video also. First of all, you have to wash with tap water. Next, you have to rinse it with distilled water. If we are using burette or pipette, we have to rinse it with appropriate solution, what we are going to measure from that measuring device. Okay. So here, if they mention 2 decimal point, 0.00 like 2 decimal points, we have to use pipette or burette. Okay. And we are doing this experiment in a stoppered bottle. We have to maintain the temperature by using a water bath containing ice cubes. At 25 we have to swirl very well. So we have to stir very well this water bath also to achieve a homogeneous or unique temperature. So how can we measure the how can we check whether our solutions whether came into the appropriate temperature? 25 degrees. We have to insert thermometers into these solutions, 4 different solutions which are in the water bath, and we have to check whether the temperature is 25 or not. Keep in mind. And how we can assure that the solutions are saturated with potassium hydrogen tartrate? We add excess amount of potassium hydrogen tartrate solution. We don't know the concentration. We add about 1 gram. We stir very well, or we swirl very well, and we try to dissolve everything, but after 20 to 17 minutes, 20 or above minutes, we can see there are some undissolved potassium hydrogen tartrate deposited on the bottom. So we know that now the solution is saturated. We can assure. Okay. We use 4 different ionic strength solutions. To achieve that ionic strength, we use sodium sulfate solutions. 4 different concentration containing sodium sulfate solution we used. Okay. To measure that 10 ml of reaction mixture or 10 ml of this solution, we use pipette, 10 ml pipette or 10 ml graduated pipette. Okay. Those are the special things. Every time we have to label all the glasswares, and we have to clean every glasswares before using. So we have to consider the temperature also. So those are the important things in this practical session. So this is very small summary. Please read the book also. Next we will move into our third experiment.